Hello, everyone. This is going over Chapter 6, which is dealing with fingerprints. So the next three slides are just a summary of what we'll be talking about and then also a list of vocabulary. So you can get those by looking at the PowerPoint or pausing at these locations if you want to see what we're going to be going over. Starting with the introduction, no two people have the exact same fingerprints, so this is why it's considered identical. So this is why it's considered individual evidence. Not even twins, and I'll explain that coming up later on as I discuss how they are made during development. You can gain scars, but those scars are also unchanged, and what will happen is that will just make it more individual to you, especially if you're a suspect within the lineup. Next couple slides are just going over the history, and I'll pinpoint out specific ones that you'll need to make sure you know. So know this one here, about 4,000 years ago, signatures on clay tablets were the first known use of fingerprints, and this was just used for land purposes and transfer of money. In the late 1700s, Andreas Mayer first noted no two fingerprints are the same. Not necessarily that you need to know this individual. 1856, Sir William Herschel started collecting fingerprints and noted that they didn't change with age. This individual you would need to take note of. 1879, Alphonse Bertillon. He is assistant clerk with the Paris police station, and he created a way to identify criminals with physical measurements and fingerprints. The criminal system was having trouble in determining the differences in certain criminals. So what they did is they took fingerprints, and then you can see in this picture here that to the right, he took various measurements like height, wingspan, circumference of the head, and such forth. This is another person you need to note down, and mainly you just need to note down that Sir Francis Galton, he developed a fingerprint classification system that we use today. And then this other person you'll need to note down, which is Sir Edmund Richard Henry. He developed a system of classifying fingerprints into loops, whorls, and arches. And this led to record keeping that Galton used, which was the tens card, where you collect all 10 fingerprints. So right here, these are rolls. So you physically roll your finger on this piece of paper here for the right hand and left hand. And then these down here are presses of all 5 fingers. I'll come to this slide later on. Fingerprints. So the formation of fingerprints happens during the 10th week, and depending upon how you lay in the womb is how those 3 types of fingerprints develop. Okay, they develop in the basal layer of the skin, and I'll talk about the different structures of the skin coming up. But the purpose is to help you grip objects, and then they are starting to collect other prints like the palms and soles of the feet. The FBI is, at least palms, I know they are. Here we have different layers of the skin. So we have the epidermis, which just means upon the dermis. Okay, so the epidermis is the outer layer of the skin. It's the actual surface. Okay, and then you have the dermis and then the hypodermis or subcutaneous tissue down below. These are pretty much the 3 layers of skin. Okay, and then right here is the basal layer, which is in between the epidermis and dermis. And this is where you have the dermal papillae, and this is right below the basal layer, the top layer of the dermis. And what happens is this is the area where the ridge patterns are formed. What happens is during this 10th week, they start growing very, very rapidly, and so they start folding over, and this creates these ridge patterns. In certain areas, they don't grow very rapidly, and you don't get these ridge patterns because they're just very smooth. All right. So what happens is the basal layer separates from the epidermis from the dermis, like you see here, okay, and that just connects those two. So the next I'm going to just simply talk about the different types of loops, arches, and whirls. You can see loops are the most common in the United States, whirls are next, and then arch is next after that. So before I get into greater detail about each one, we have to look at what's our characteristics of fingerprints, and you'll see me talk about more characteristics after this groups of fingerprinting. But you have what's known as the core, and this is the center of a whirl or a loop. A arch will not have a core. Okay. Then we have deltas. You'll find one delta in a loop, and then you'll find two deltas in a whirl. And this is what a delta would look like. Okay, it looks like a triangle. All right. You can get what's called a ridge count. So all you do is you find your core, your delta, you make a line, and you count how many ridges you cut through for each of that. And that will get you a ridge count. All right. This will help distinguish one finger from another. So arches. Arches are ridges that enter from one side and exit out the other side. There are no deltas present. And you have two types of arches. You have a plain arch and then you have a tinted arch. You can see how this much more has a greater arch to it. Okay, so let me get in. So right here you can see how it goes in, out. And then the tinted arch, it just has a much greater arch to it. So here I've already sort of drawn on here, but this is loops. You have ridges that enter and leave on the same side. Okay, so you can have what's called an ulnar loop or a radial loop. Okay, so if you just look at your right thumb, on the inside, so you have two bones. You have the radial bone and you have the ulnar bone. The radial bone is on the thumb side. The ulnar bone is on the pinky side. Okay. So if the loop opens up towards the ulnar bone, okay, then it's called an ulnar loop. If the loop opens up towards the radial bone, then it's called a radial loop. All right, and such forth. Okay, and then it has one delta. So like we see here, there's a delta, and then a loop comes in one side and exit out the same side it came in. All right. And again, if the loop opens up towards the right, it's called a ulnar loop. If the loop opens up toward the radius, then it's called a radial loop. All right, and that's just where you just simply look at your hand. And so if it opens up towards the ulna, which is inside, then it's going to be ulnar loop. If it opens up towards the thumb, then it's a radial loop. Next are whirls. These are ridges that make a complete circuit, like you see here. Okay, and they have two deltas. All right, and you have what's called a plane whirl and a central pocket whirl. So what you do is you just find the two deltas. You draw a line in between them. If this the whirls crosses that line, then it's known as a plane whirl. If the whirls do not cross that line, then it's known as a central pocket whirl. Okay. Next are two different types of whirls. One's called a double loop whirl, and you can see where I've already sort of tried to draw. This is where two loops come together. Looks like a yin and yang signal, and then you have two deltas. One delta from one loop, another delta from another loop. Okay, and then you have what's called an accidental whirl. It doesn't have to look like this, but you just see it interconnecting. So like right here, you sort of got this mushroom effect. Okay. This is where there's like no structure, so they're just going to call it an accidental whirl. It's as long as they see two deltas. We see one here, and then we'll see another one right in here. Okay. So right here we just have fingerprints that I want you to help identify. So right here we see two deltas that I've marked. Okay, and so this is going to be called a whirl. All right. Then here we have 0 deltas, the circle. So this will be an arch because it enters in one side and exits out the other. And then right here we have a single delta, and you can see it enters and exits. So this is just going to be a simple loop. Okay, and this is opening up towards the radius, which is going to be thumb side. So that is going to be a radial loop. Okay. And then we can identify these. So just try to guess what this is, and then I'll just show you up. This is on the right hand. Okay. If you want to pause, you can pause here. This is on the right hand also. So if this is the owner, then this must be the opposite direction. So this is a radial loop. Okay. And right here I circled 2 deltas. So this will be a whirl. All right. One more time. Okay. So you can see we have this yin and yang. You can see a delta here and then another delta here. So you know we have a whirl. And this is a double loop whirl. Right here you can see a delta. Okay. And you see an enter and exi on the same side. So that's on the left hand. And that's a loop owner. And then right here we have another whirl. Okay, so the other thing is minutia. So when it talks about 6 points of references, it's just talking about these different minutiae that I circled here. Okay, let me see if I can get a... No. All right, well, so we have just different minutia, different details, and we'll talk about more of these in class. Next are just 3 types of how fingerprints are left at a crime scene. You have patent fingerprints, which are visible prints. So this is like if you see a fingerprint in blood or some type of oil, and it's left on a smooth surface. You have plastic prints, which is left in a softer material like clay or wax, so it gives it more 3-dimension. And then you have latent fingerprints, which are invisible fingerprints because of the oils that are naturally on your skin, but you can bring these oils and about using powders or chemicals. So you'll need to note this down from your textbook. These are just different methods that you could use. I'm going to go over a couple of them, but you can find this table on page 167. Okay, page 167. So I have an idea about uses, application, okay, and then what it's going to look like, the latent print. So right here we have uses, application, and then the color that will actually come about for the latent print. Okay. So this one you'll definitely need to know because we'll actually do this in class by using carbon or talc powder, and then you can pull those off of like window like you see here, and just using a brush, and you collect it with tape. We will not do this one. Okay, actually we may do this one because I actually have anhydrine. All right, but this is if it reacts with amino acids and it turns purple, and then you're able to take a picture and store it in the FBI database. We'll hopefully do this one. This is cyanocrylate. You'll get to keep your own slide with super glue. And what it does is the super glue sticks those amino acids, fingerprints on the glass, plastic, metal, and skin. And you'll see that huge air science thing in the back of my room. That's what it's for. Okay. And you get that. Just take a picture. Okay, I'm not going to go over this one. You can read that. Same thing with the iodine. Just again, look over the table for those. I'm just trying to make sure this PowerPoint is not very long. This one's pretty neat. So this is like when you see the UV light. So they can use what's called fluorochromes, and then it's going to glow with the presence of UV light. So all these prints are going to be stored in what's known as the Integrated Automated Fingerprint Identification System. Has more than 76 million prints. They also have mugshot scars, tattoo photos, and other identifiers. Okay, but these digital searches can be made within 2 hours. And what it does is the computer will pull out possible matches, and then a technician will need to actually identify those matches using a comparison microscope or a computer in this case. The future of fingerprinting is by using the pores. So by identifying the pores, you can actually get a far greater detail in stating that this is the person. Because there are instances where there is faulty fingerprinting. But this is the end of the PowerPoint. I hope this helps. I hope you have a great day. Bye.